Okay, boys and girls, so on this one, we are working on comparing fractions. And we're going to go over when the numerator's the same, when the denominator's the same, and when both, and I'm going to shorten it, numerator and denominator are different. Okay? So, we're going to start off right now with the numerator the same. So, we learned before, and I'm just going to draw it out so we can relearn. So, I have my two fraction bars, and I'm going to split the first one into 4 pieces. And I color 3 of them. Now, for the next one, I need to split it into 8 pieces. Just like this. And I color, once again, 3 of them. Which one has more filled out? 3/4 or 3/8? Which one's closer to being a whole? You're right, 3/4 was. So in the end, 3/4 is greater than 3/8. Now I want you to look at this next one. It has 2/3 and 2/6. So I draw my fraction bars, split the first one into thirds, and color 2 of them. Then I split my next fraction bar into 6 pieces, and once again, color 2 of the 6 pieces. Which one is closer to 1 whole? You're right, 2/3 was. So our rule is, whichever number in the denominator, when the numerator is the same, we look at the denominator, and whichever number is smaller is bigger or greater than the other one. So that's our rule for when numerators are the same. Now let's talk about when denominators are the same. I'm going to draw it out again like I did on the numerators, just so we can remember. I split it into 4 pieces. I'm going to do it my way, 4, and I color in 1 of them. Then I split the next one into 4 pieces, and I color in 3 of them. Which one's closer to 1 whole? 1/4 or 3/4? You're right, 3/4 was the greater fraction. Now let's do it for this one. I cut it into 6 pieces. Do the same thing. I can just follow the lines from the top one because they're the same. So this first one I color in 5 pieces. The next one I color in 2. Which one's closer to 1 whole? You're right, 5/6 was. So my rule for when denominators are the same, when the denominator is the same, you look at the numerator, and whichever number is bigger is the greater fraction. That is my rule for when the denominators are the same. Now there's going to be times, like in this problem, where your denominators are not the same. And this is one that this is one that is on your review. So this is one of the problems you're going to do today. So I'm not going to finish the whole thing, but I'm going to get you started on it. So if I look, it says a trail is 7/12 mile long. Select the trail length that is shorter, I'm going to box it, shorter than 7/12 mile. Mark all that apply. So that means when it says mark all that apply, that means there could be more than one answer. So I need to check all of them to see if they're possible solutions. So if I were to do this, if I were you guys, I would take this and I would compare to each one. So that means I would do 7/12 compared to 3/8, 7/12 compared to 2/3, 7/12 compared to 3/4, and then also 7/12 compared to 1/2. I will help you with this first one. You will have to do the other ones on your own. So I have 12 and I have 8. I have to think to myself, I think to myself, right now I can't compare them. They're not the same denominators. So I need to find a way to get them to be the same denominators. I want you to think, 8's the smaller one. Is there anything I can multiply 8 by to get to 12? No, there's not. So the first strategy that I taught you before is not going to work. Now, let's say that, so now what I'm going to do for this one is I'm going to do the strategy where I multiply my denominators together. So I'm going to do 12 times 8. Well, what's 12 times 8? 12 times 8 would be 96. So I now have my new denominator that's going to replace the 12 and the 8. But if I do that, don't I have to change my numerators? The answer is yes, I do. So I need to switch them both. So I'm going to take 7/12 and I multiplied it by 8. So if I multiply the bottom by 8, I have to multiply the top by 8. I already know my new denominator is going to be 96 because I found that out right there. So what's 7 times 8? You're right, 56. So that is my new equivalent fraction for 7/12. Now I have to find an equivalent fraction for 3/8. So I know I need to multiply it by 12. And I know that because I had to multiply 8 by 12 to get to 96, which you can see right here. That gave me 96, so now my denominators are the same. Then 3 times 12 is 36. This right here is my equivalent fraction for 3/8. So I have a question. Is 7/12 or is 5696 or 3696? Which one's bigger? You're right. 5696 would be bigger. So in the end, 7/12 was greater than 3/8. So that means 3/8 is shorter than 7/12. So that means I would color that in. Because in the end, 7/12 is greater. Every time that you see that this is greater, like that, meaning that 7/12 was the bigger fraction, that makes this the smaller fraction or smaller length. So now your job is to go through and check these ones out. You can use any of the strategies we learned before. Remember, the first strategy is to see if you can multiply one denominator to be the other. So like, look at this one. Is there anything I can multiply 3 by to get to 12? There is. I would multiply it by 4. So that means I only have to change this one. Okay? Do your best with it. If you need help, message me and I can help you. Last one. This is also a problem that I'm going to help you get started with. It says on average a chimpanzee spends 2/5 of the day sleeping. A squirrel spends 5/8 of the day sleeping. A three-toed sloth spends 5/6 of the day sleeping. For these, you need to compare them to each other. So this first one says, a chimpanzee spends more time of the day sleeping than a three-toed sloth. So that means I need to take the time of the chimpanzee, which was 2/5, and I need to compare it with the three-toed sloth. And that was 5/6. So with that, it's wanting this, it says, because it says a chimpanzee spends more of the day. That means it wants it to end up looking like this. But we have to check to make sure it really does do that. So we're going to take 2/5 and 5/6. And I'm going to do the step where I multiply them together. So 5 times 6 is 30. This is going to be my new denominator for both of them. I just need to change them to be that way. So I take 2/5 and I multiply it by the same number to get the denominator 30. What would I have to multiply 5 by to get to 30? You're right, 6. And if I do it to the denominator, I do it to the numerator. And I now have my new equivalent fraction for 2/5. Now for 5/6, I need to, once again, get it to be the same denominator of 30. So I ask myself, 6 times what equals 30? Would be 5. 6 times 5 is 30, so then I multiply the top, I get 25. So, I have a question. Which one's bigger? 12/30 or 25/30? You're right. 25/30 was bigger. So in the end, 5/6, so it was 2/5 is less than 5/6. Does this match what the problem wanted it to be? No, it doesn't. So that means it's false. So 6/8 is false. You're going to do the same exact concept where you take the next one. A squirrel spends more of the day sleeping than a chimpanzee. So you're going to compare the squirrel and the chimpanzee and see if the squirrel does spend more of the day. If it doesn't, then it's false. If it does, then it's true. And you keep going through all the animals and see which one is correct. Okay, I hope this helps. But before I end, I want to make this point really clear. A chimpanzee sleeps more than the other two types of animals. Pay really close attention to that one. Don't let it trick you. Okay, if you need help, I'm on Google Hangouts. Bye, guys.